Hello everyone, welcome to Basic Electronics classes. Today I am taking the topic Operational Amplifier. I am Lavanya Vaishnavi. This is session 6. So for more videos you can refer my channel. What are all the topics I am covering today? Numericals on OpAmp. Like what and all the topics I have discussed in the previous session. Based on that I am teaching some numericals today.
Hello dear students, welcome back to operational amplifier classes. Today I am going to start with some problems, like a few problems which are important for the exam, and so using the concepts what we have studied in the previous sessions, using them we are going to solve this. So using the equation, it is better that I suggest you to take a calculator and start solving the problems. Okay, so please take pen, paper with a calculator and start solving the problems. Now, for the first problem, for the operational amplifier circuit shown below, find the output and closed loop gain. So you need to find the closed loop gain, that is AV, and also you need to find the output. So find the output V naught. The two parameters you have to find it out. So in this, what is the circuit given? You have a circuit with positive feedback. You have two resistors here, 3.9 kilo ohm as a feedback one, and 100 ohm which is connected to ground. 50 millivolts is the voltage source that is given to inverting terminal. Now I need to find what is the output voltage. First let us calculate the output voltage. To calculate the output voltage, I know that like point A and B are at the same potential, right? Because of virtual ground, A and B are at the same potential. It means that B and this point both are same, right? So this is B and also this is B. I can say both are at the same potential. So whatever VA is there, the same thing you will be getting here. What is the voltage at point A? It is 50 millivolts, which is equal to V in. That is, even B is in the voltage V in. Okay, B is also in the same voltage V in. So I can write VA is equal to 50 millivolts and VB is also equal to 50 millivolts. Okay, so VA, VB both are equal to 50 millivolts. And also we know that the current flowing towards the OpAmp is equal to 0. IB is equal to 0. So there is no current flowing towards the OpAmp because the input impedance of OpAmp is infinity. Input impedance of the OpAmp is infinity. Now, taking this concept, here I can calculate V0. So before calculating V0, I need the current here. So IF. So look at this, IF is equal to, I know the voltage, that is potential drop across these 2 points, that is V in. So V in divided by R, V in divided by R. What is the value of V in? It is equal to 50 milli divided by 100, which is 0.5 milliamp. So using the calculator, you will get the value as 0.5 milliamp. If this is the value of IF, see, in the circuit, I can clearly say, because there is no current flowing here, the same current is flowing across 3.9 also. Now, I'll write only this part of the circuit. So, it becomes V out 3.9 kilo ohm, and this is point B, which is at the potential V in, which is 50 millivolts, right? And here you have 100 ohm and then ground. So here you have the current IB flowing, but the value of IB equal to 0. So I can just ignore this, right? Now I know the current here, which is 0.5 milliamps, and also what is the voltage drop? 50 millivolts. What is the voltage drop from here to here? That we need to calculate. So that is, voltage drop across 100 ohm is 50 milliohm. 50 millivolts. So what is the voltage drop across 3.9 kilo ohm? So 3.9 kilo voltage drop across 3.9 kilo is equal to, so we know that V is equal to I into R. I into R. I is 0.5 milliamps. R is, so 3.9 kilo ohms. So what is the value now? V across 3.9 kilo ohm is equal to, so it is approximately 1.95 volts. 1.95 volt. I need the value of V0 now, right? I need the value of V naught. So okay, V naught is equal to, so here the potential drop between this plus this, that is voltage across 3.9 kilo ohm plus voltage across 100 ohm, which is 1.95 plus 50 millivolts. So V naught is equal to 2 volt. V naught is equal to 2 volt. So this is how you calculate the output voltage. Now I need to calculate what is the value of open loop gain. AV is equal to output by input. What is the output? 2 volt divided by 50 milli is the input. So what is the value? So the value is equal to 40. 2 volt divided by 50 milli is equal to 40. So open loop gain value is 40. So this is about the first problem. Now coming to the second problem. In the second problem, it is described as, in the circuit below, RL is the transducer resistance which can vary from 1 kilo to 10 kilo. Determine the range of variation of output voltage. Now you have a circuit here. What sort of circuit it is? It is an inverting amplifier. What it is? It is an inverting amplifier. Okay, it is inverting amplifier. So in this inverting amplifier, you have a RL. What is RL? He says that it is a transducer resistance. What is it? Transducer resistance. What is a transducer? So if you have what is a transducer? Transducer is a resistor that changes its resistance value with the physical properties. Say for example, if you just assume the weighing machine. So in those weighing machine, as the pressure increases, you can see the scale deviating, right? I mean, digital weighing machine, if you take, automatically the value of the weight will increase or decrease according to the weight. How does it happens? Because of this transducer. Here you just understand that RL is a resistance that can vary its resistance from 1K to 10K. Okay, so transducers are the resistors which changes its resistance value according to the physical property varies. Okay, so here RL is a resistor that varies from 1K to 10K. Oh, okay, so now again coming to the analysis part, I'll take this point as A and let this point be B. Okay, so this is point A and this is point B. Now A and B both are at the same potential, right? Both are at the same potential. I'll assume here you have a virtual ground. Here you have a virtual ground. Now I need to find out what is IL and what is this current and what is IB. We know that current flowing towards the OpAmp, bias current, is almost equal to 0 because input impedance is infinity. Input impedance is infinity. Because the input impedance is infinity, current flowing through towards the bias, towards the OpAmp is 0. So whatever the current comes, it flows through the RL and go to the output. So potential at this point is same as V0. So it is V0 potential. Here it is 0. VA is at 0. So VA is equal to 0. VB is equal to 0. And so how do you define current I1? The current I1 is defined as, so from where to where the current is flowing? From the source to point A. It means it is 10 minus VA divided by R will give you the value of I1. Okay. So here I1 is equal to IF, right? So I1 is equal to IL. Sorry, it is IL. So I1 is equal to IL. Therefore, I1 is equal to IL. So if I write I1 is equal to IL, then what is the value of I1? The value of I1 is, okay, the value of I1 is, so here you can see 10 minus 0. 10 minus VA divided by, what is the resistance it is flowing through? It is flowing through the resistance 100 kilo ohm. So 100 kilo is equal to, what is IL? It is 0 minus V0. So 0 minus V0 divided by RL. 0 minus V0 divided by RL. So RL value is varying here. So I am not taking the value. VA value is 0. So it becomes 10 minus 10 100K is equal to minus V0 divided by RL. I'll write the expression for V0. V0 is equal to 0 and 0 get cancelled here. RL minus RL divided by 10K. V0 is equal to minus RL divided by 10K. So the range of RL is 1K to 10K, right? It is 1K to 10K. Therefore, the voltage V0 varies from, so to this expression apply 1K. It becomes 1K divided by 10K. What is 1K divided by 10K? It is 0.1 volt. Okay. 2. For this one, apply 10K divided by 10K. It becomes minus 1 volt. So the voltage ranges from minus 0.1 volts to minus 1 volt. So this is how you calculate the range of output voltage for a transducer. Okay. So as the resistance varies from 1K to 10K, it says that the output voltage varies from 0.1 volt to 1 minus 1 volt, minus 0.1 volt to minus 1 volt. Okay. So the next problem is a simple problem where for the OpAmp circuit, find the output voltage V0. You need to find the output voltage V0. Even though the circuit seems to be slightly bigger, it is very simple. Okay. So here you have a amplifier, inverting amplifier, and this is an inverting amplifier again. So in this amplifier you are giving a current of 1 microamp and you are taking at V1. This V1 is the input for the second stage and you are taking across output across RL. Now when 1 microamp is given here, I'll take this as I1. Okay, I'll take this as I1. So here I'll take the current flowing towards 10K as I2 I'll take. Okay, so I'll take it as I2. So because IB is 0, I can take I1 is equal to I2, right? Whatever the current comes, it flows across 10K. Okay, so which is equal to 1 microamp. Correct? So it is 1 microamp. The same 1 microamp will flow across this and it reaches the point V1. Now, what is the direction of I2? It is from this point, say this is point A to V1. What is the potential at A? It is equal to 0 because this point is grounded, virtually grounded. So, I2 is equal to VA minus V1 divided by 10K. VA is 0 minus V1 divided by 10K. I know I2. Now find out V1. V1 is equal to I2 value is 1 microamps and into 10K. Okay. So into 10K. So you have minus sign here. V1 is equal to minus of 1 microamp into 10K. So V1 is V1 is equal to minus 10 millivolts. So now I got the value of V1. Now if I got the value of V1, what is the next step I want to do? See here, again I can make sure that V1 and V2 are at the same potential. It is similar to problem number 1, right? So I'll take only take this part of the circuit. It becomes, so here you have 99K. This is V2 point. You have 1K. This is the ground. Units is ohm. From here you are taking the output V0. You know what is V2. This is V2. Okay. And this is some Vx I'll take. Vx. Now I need to calculate Vx to find out what is V0. V0 is equal to Vx plus V2, right? This sum is equal to V0. We already know what is V2. V2 is equal to V1, which is equal to, so here I have calculated, right? 10 millivolts. So it is minus 10 millivolts. Sorry, okay na? So next step, So this is done. Now I need to find the value here. So I know current here. I want to find the current here. So current I will find it out. So how to find the current? Current I. So I'll take it as I1. Okay. I1 is equal to, current I1 is equal to, what is the voltage here? The voltage is 10 milli, minus 10 milli divided by 1K, minus 10 milli divided by 1K. So I1 is equal to 0.01 milliamps. I1 is equal to 0.01 milliamps. So here also you will be having the same current, right? So if it is minus, it means that it is flowing in the reverse direction. Okay, so it is flowing in the reverse direction. So whatever the direction may be, I just need the value of voltage here. So Vx is equal to, so now I need to calculate Vx. I know the current. So what is the current? 0.01 milliamps into minus, so into, what is the resistance? 99 kilo ohm. So Vx is equal to, Vx value is equal to 0.99 volts. So it is minus 0.99 volts. As I said, V0 is equal to Vx plus V2 minus 0.99 volt plus minus 0.01 plus minus 10 millivolts, right, is equal to 1 volt, minus 1 volt. Okay, so this is the output voltage. If the next problem is determine V0 for the circuit. In this is the summing circuit where you are giving the input to inverting terminal, and RF is 500 kilo ohm, R1 and R2 are given here. I need to find the value of V0. We know the expression V0 is equal to minus RF divided by R1 into V1 plus RF divided by R2 into V2. Okay, so if you have one more set, you will write plus RF divided by R3 into V3. I have only two inputs, so I will take only two variables is enough. So minus, what is the value of RF? 500 kilo divided by 100 kilo. So 500 divided by 100 into, what is the input? Minus 2. Minus 2 plus 500 kilo divided by 200 kilo into, what is the value of input? Minus 3. So it is minus 3. Okay, what is the next step? So just cancel this. This becomes 5, and 5 by 2 into minus 3. This becomes 5 2s are minus 10, minus 7.5 you will get. Yes, so it becomes 17.5 volts. If you add it, V0 is equal to 17.5 volts. Okay, so this is the equation, or this is the value of output. Clear with us? It is just a simple problem. Okay. The next problem is, for the amplifier circuit, find the output voltage V0. So this is very similar to the very first problem what we have solved today. So the same thing, this point, or let me take this point A and let this be point B. So you don't have any component in between these two nodes. So B and B both are same. Now I need to find V0. To find V0, I need to know what is the resistance at this, across this resistance, and what is the voltage drop across this resistance. What is the voltage drop here and here? If you find it out, you can finally find V0. So what is the potential at B? It is equal to potential at A. VB equal to VA, which is equal to minus 2 volts. Okay. Now this VB is equal to minus 2 volts. Yes. In the second step, I can write it like, so I need to find the current. I assume that the current is flowing in this direction. Because there is no current IB, I will take the current I here. Both have the same current I. So IB is equal to 0, right? So IB is equal to 0. So I is equal to, I know the voltage drop from this point to ground, which is VA. So VA divided by 200K. Okay, VA divided by 200K. So I is equal to, so what is the value? Oh, I missed minus here, right? So minus, it is VA. Okay, minus 2 divided by 200K, which is equal to 10 microamps. I is equal to 10 minus 10 microamps. Fine. So the next one is I have to find the voltage drop across this resistance. To find the voltage drop, so Vx I'll take Vx. So voltage drop, let it be Vx. Vx is equal to 500 kilo into minus 10 microamps, which is equal to, so the value of this is 5 volts minus 5 volts. So Vx is equal to minus 5 volts, and hence V0 is equal to minus 5 minus 2, which is minus 7 volts. Okay, so this is the value of V0. Next problem is, for the OpAmp circuit, find the output voltages and also the value of current if V1 is equal to 2, V2 is equal to 4 and V3 is equal to 6 volts. It is very simple to calculate. So we know the expressions, right? We know the expression. Using the expression, we are going to calculate. And look at this point. These two are the same points, that is VA. And this is at the potential 0. VA voltage is equal to VB voltage, which is equal to 0. So VB equal to 0. Hence, so VA equal to 0. So I1 can be defined as I1 is equal to V1 minus VA divided by 10K. Okay, I2 is equal to V2 minus VA divided by, it is 20K. Okay, I3 is equal to V3 minus VA divided by 30K, which is equal to V1 is at the potential 2 volts. 2 minus 0 divided by 10. This is 4 minus 0 divided by 20K. It is K. And here it is 6 divided by 30K. Okay, now find the values. So the value of this will be 0.2 milliamps. It is 0.4 milliamps. And this is 0.2 milliamps. Okay, so this is the values of current. So I know the expression for output. So no need to calculate the other part. Directly I know the expression. So I'll write V0 is equal to minus of RF divided by R1 into V1 plus RF divided by R2 into V2 plus RF divided by R3 into V3. Fine. Now, which is equal to minus of RF. What is the value of RF? So, RF is 40K, right? RF is 40K and R1 is 10K, 20K and this is R3 30K. Now, so RF 40K divided by 10K into 2 plus 40K divided by 20K into 4 plus 40K divided by 30K into 6. Okay, so now twice, and this is 4 by 3 times of 6, 2 times, so it becomes minus 4 2s are 8 plus 2 4s are 8 plus 4 2s are 8, so it is minus 24 volts. V0 is equal to minus 24 volts. So these are the few problems that are discussed in this chapter. So for more problems, you can refer the prescribed books.
Thank you. Thank you for watching this video. Please like the video, share with your friends and subscribe to my channel.